Okay, so we're going to be doing example 4C5. In this problem, a basketball comes in with a speed of v1, bounces off the ground, and exits with a speed of v2. Our givens are the weight, 1.3 pounds, v1 is 20 feet per second, v2, 17 feet per second, this theta here, 20 degrees, and our time of impact, or change in, or delta t, is 0.01 seconds. So over here, we know that this angle is 20 degrees. We can split that in half. We'll have 10 degrees on this side, 10 degrees on this side. So now we know we have a 90-degree angle here. 90 minus 10 will give us 80 degrees, and 80 degrees over here. We will call this angle C. So now we are going to, also we have a coordinate system here. So this is going to be our T direction, and coming down is going to be our N direction. So now that we know that, we'll do our free body diagram. We have our weight force going down, and our force average is going to be acting straight up. All right, I'll now pass it off.
Okay. We're going to use the Newton's second law, the momentum equation. So we're going to have T2 to T1 equals mass times V2 in the direction minus V1 in the direction, which is going to give us, because the weight is in the positive direction, it's going to be positive minus the force times delta T equals mass sine phi 2 minus N1. I'm going to pass this to Mikey.
All right, thank you. So we want to solve for this F average. So first we're going to distribute this delta T to this left side of the equation. So we're going to have a weight, it's delta T minus the F average, delta T, and that's going to equal the same thing on this right side, the mass, sine of phi, times the two velocities minus each other, v2 minus v1. So I'm going to move over here to this next whiteboard because I'm out of room. So I'll rewrite up here on top what I just wrote down over there so you can see minus the force average, delta T equals the mass, sine of phi times v2 minus v1. So, like I said, we want to solve for the F average. So we could add this to this right side, subtract this from that side to keep all the signs positive. After doing that, you're going to have the F average times delta T equal to the weight times delta T minus the mass, the sine of phi times the quantity of V2 minus V1. Now all we have to do is divide by delta T. So doing that, we have the average force is the weight delta T minus the mass, sine of phi, V2 minus V1 over delta T. Now, we have enough information to plug in and solve for all of these. Now, you might be thinking we don't have the mass, but we know that weight equals mass times gravity. And they gave us the weight, and we know that gravity is 32.2 feet per second squared, so I'll write that out. 32.2 feet per second squared. So we're going to substitute mass with weight over gravity into this equation. So now we have the average force is weight delta T minus weight over gravity, sine of phi, or final minus our initial velocity, over the change in T. Now once you plug this into your calculator, you're going to get 13.27 pound force. Now I'll prove to you that the units end up being 13.27 pound force. I'll plug in all the numbers. So our weight was 1.3 pounds, and that's pounds force, times 0.01 seconds. And we're subtracting 1.3 pound force over 32.2 feet per second squared. This is all multiplied by the sine of 80, and then our velocities, which are V2 is 17 feet per second, and that's minus V1, which is 20 feet per second. And this is all divided by 0.01 seconds. So I'll show you unit-wise. So we know that a pound force is the same as a pound mass foot per second squared. So this pound force is the same as pound mass foot per second squared. And that's being multiplied by another second. So this chunk right here, this left piece, ends up being, these seconds cancel, ends up being pound mass feet per second. And this right piece, so like I just said, pound force is a pound mass foot per second squared. We're dividing it by a foot per second squared. So we're just gonna end up, this fraction right here is just pound mass times feet per second. So we have that whole right side, it's pound mass feet per second also, which is good. We want them to be the same units, that way we can subtract them. And then we're going to divide that by seconds, which is going to end up being pound mass feet per second squared, which we just said was pound force, which is our final answer right here. It's 13.27 pound force. Thank you for watching.